Let me
what?
try and use my whether my
Maybe
phone will work. Let
no.
me try and use my phone to connect it.
You know what?
Because
Don't worry. You know what you are going to do after this class. Maybe if you are opportune, you can work it by. I'll give some classwork to work on. Then you can
okay.
probably make a video. Like make, I don't know. Do you have a screen recorder on your laptop? I don't know, sure, but we'll talk about that later, sure. But you make a screen record
Okay.
of like the queries and everything, and you send it to me on
Alright.
WhatsApp. So
Okay.
yeah, so let's proceed. Introduction to relational database and MySQL. Let me open MySQL bench. Yeah. Okay. So let me stop sharing the. Okay. Let me just present something as basically. Yeah. So basically, introduction to relational database and MySQL. Like I've discussed in our last class, what is a relational database? But before we talk about that, we need to understand what you mean by database. Eh, Yeah, a database is basically a a storehouse in which we store informations, and it could be any information. It could be I don't want to go too broad actually. It could be information about a school, information about a business organization, a company, or some other things. But before you can access the database and manage the database, get information about the database, update information about the database, or whatsoever I want to do with our database, we need to have a key to the database. It's called a relational database management system. So in other words, a relational database management system is basically a, a tool that is used in managing our database. So there are various types of relational database management systems that we have. We have MySQL, which we are currently using. We have the Postgres SQL. We have the Oracle database. Um, we have the Oracle database. We have and so many and many more. Each of them are actually unique in their way they write their queries. For example, MySQL has its own way in writing its own query that makes it unique. Uh, Also, Postgres has its own unique way of writing its own query. Oracle has its own way of writing its query. So, I just want you to know that in case probably when you start working for a company, you need to specify which type of DBMS you work with, so that they will like need to understand. Okay, because basically the company would have actually known differences between each particular DBMS that you are working with. So when you specify them, they will know how they will tax you, like how they will assign your job to you, what to do and what not to do. Now we've talked about database, we've talked about DBMS. It remains RDBMS. Now RDBMS, if you can notice, is basically that we are adding letter R to DBMS. Now RDBMS basically stands for relational database management system, and what it does is like it allows us to break down a large information and split it down into pieces, so we can better understand the database, yeah, basically in total. Let me use that word, in total, so that we can understand how the data is being collected and stored into the database. Okay, let me use an example of a school of a university, for example. Obviously, university is going to contain large information of people, and if you put that information in an Excel sheet, it's going to be very very large. And let's say you want to store it in a database, storing that large information just like that's an Excel file without having any information about what is going on, how data is being collected, um, without having any basic insight about our information, is basically um, just basically like storing raw information. You don't have any insight about anything or anything. So instead, we create what is called clusters or groupings. Yeah, basically, let me use what clusters. Clusters basically mean clusters basically mean you are grouping informations based on similarities. So, in the case of a school, when we have large data sets, we can group them into clusters such as departments. So in that way, we've already known that okay, students can be grouped into departments. You know that universities also stores the staff information, not just the student information, right? So staffs and lecturers informations, the and other segments of the other segments of the school information details. Now, after I've already grouped them and clustered them, we now need to map out the relationships. And you know that in school, in a school, basically, teachers actually teach students, and students actually enroll in some courses. So we need to also have a cluster called courses enrolled. I don't know if you understand what I'm trying to say though, but what I'm doing basically is called an ER diagram that we did, that we practiced together during the first life class that we did. That diagram that we're drawing is basically what I'm trying to imagine with you currently. So we create an enrollment table. Then by that way we can know that a particular student should be able to enroll into one or more number of courses. That way we can have a visual insight about our data. Like we can know that okay, fine, Stanley was able to enroll in okay, Stanley is allowed to enroll in many courses based on what our data set allows, based on what our database accepted. So we can know that okay, we'll be expecting a minimum of one course from Stanley to be registered. So by that we've already clustered, already grouped our data into clusters and assigned some relationships. You can also know that some staffs should be assigned to some departments. So that process is called an entity relationship diagram, and the process whereby the data is being mapped out into relationship is called conceptual view, and the process whereby is actually grouped into it's created the process whereby the database is actually created is called a logical or physical view. So there are three phases when building the database, which I've basically explained to us. So we've already covered introduction to a relational database. So that's just the theory part actually, and every data analyst needs to know that. So I want to be talking about the installation setup because we've actually talked about it earlier, and I'll basically skip that part. So now I will talking about okay, I will talking about primary key. We've talked about it before as well, but what is a primary key? A primary key is basically a colon. We know what colon means from Excel, that allows us to uniquely map out each observation from a lot of observations. It's basically like a noun, like a name, like a tag attached to each particular entity. Now, taking it back to school, for example, in universities, everybody has their own matric number. For example, my matric number is MTH 2021-016. That is my name because no other person in that school can have the same matric number as I do. So that way, whenever the school wants to track out information about me, what they have to do is just go through my matric number and bring information related to me. Now, the reason why they cannot use my name is because I cannot be the only one bearing my name. Stanley might also have like 10 to 20 people bearing the same name in the school, even having the same surname as I do. You cannot know. But when you further your learning, you are going to understand what is called a composite primary key, a composite entity, a composite primary key basically. But I won't be talking about that because I don't want to ruin the concept of a primary key. So this is it. So I told you, if you also recall about in our last class, I told you that there are two ways to create a table. Either we use the ER diagram um, that we've already been doing, or we use the particular queries. So when creating a table using a particular SQL query, first thing you are going to do is to create a database, e-commerce, database and database name. So the query is written this way: create database and your database name. So okay, let me work on creating um, a student database. So I'm going to go to my query tab and new tab to current server. Okay, so create database students. Then whenever I write an SQL query, it's always ending with a semicolon. So press Ctrl Enter to run your code. As you can see, create database. This particular pane is called the terminal. Basically, it shows whenever your code has been run, if you have any errors in your code, what you need to do. So also when you start advancing in your SQL journey, probably want to go into backend, you are going to be using VS Code. The reason why VS Code is a very good environment, I support VS Code basically, is because it also incorporates AI tools, allowing us to know whether there is an error and even giving us the potential ways to correct the error instead of going online or probably through what was the name of this site, Web3 schools or something, or even using AI like ChatGPT or something. VS Code is basically useful, which I recommend as well. But that is in the latter journey. This is just the basic data analysis that we need to learn. So after I've created this database of students, then use and then the next line use we'll call back the database, use students. Yes. And another thing about SQL is that it is not case sensitive. You know that I wrote a small letter in this particular place. I'm trying to see if I can actually zoom, but I don't think I can zoom. Can you see my query?
Yes, I can see it.
Okay, good. You will call back the query and like write use students, which is basically our database name here. As you can see, if I change this S to a capital letter, as you can see, I wrote a small letter when creating database. It's still going to run, indicating that it is not case sensitive, as are shown in our terminal here. If you want to know whether we have an error, it's going to give us a cross sign here instead of a straight mark. Okay, let me give us an example. Okay, let me run this query. As you can show, since we've created the database called student already, you cannot recreate the database because it has the same name as this. So what you can just do basically is if we drop this database, then in that way we can actually recreate the database with this actual name. So when I rerun this, it will write can't create a database students. Database actually exists. As you can see, there's a cross sign here indicating that we have already created this database with the same database name. Hence it cannot create the database again because SQL really fancy uniqueness, and even if you create a database with the same name, it will get confused because whenever I want to work with the database, it will not know which one is which database you're actually working with. You get. So after we've done that, creating our tables, create table student info, then start applying our data type, student underscore id, integer, okay, student underscore name, varchar, because it's going to be a text, and 60. Actually, basically, the students details school asks for actually more than this. They ask for your medical information as well, but we're not going to get into that as well. This is just a practice, and I just want to show us how the whole query stuff works. What else do I need? Students Gmail. Also, if you recall in our last code, I said that when coding, you do not include a space bar in your code. Like you cannot write your code like this. For example, this is not allowed in coding generally. This is not allowed because Python doesn't allow it, except if you like quote it. SQL doesn't allow it. R programming doesn't allow it. At least as I know, sure, it doesn't allow it. So what else do we do? Student's name, ID, student Gmail. Okay. Okay, yeah. Primary key, student underscore ID. Sorry. Okay. Then when we run this code, as you can see, it's indicating that the code has been run. And if you want to, now that you've run the code, we need to insert some values, some informations into the data. So insert into students. Okay. Students info values, right? When you are inserting informations, you need to follow the same colon that like we did in arrangement order. So for example, whenever you're inserting your informations, student ID comes first. Also, I'm also recording this video. I will send it to the classroom. I cannot send it to your WhatsApp because it's going to be too large, and yeah, WhatsApp will not even allow me to send it actually. It'll just be loading. So instead I send it to my classroom, and I also be uploading it to my YouTube channel actually. So student ID, which is an integer, student's name is a varchar. I'm coming 1 second. I need to update something. Okay, student's name varchar, student's Gmail. So that's the process we are going to follow when inserting our values. So we are going to start with case 1001. Student's name Stanley. I like using myself as an example actually. Student Gmail. Let me use my actual Gmail. Okay. 1002. And there's a name they call it is actually, I think okay, you want us go there actually, let me use my freelancing name, Stanley Albage. Okay. Like I said, whenever you finish writing your query, you're going to semicolon. Okay, let's insert one more response. 1000 and sorry. Okay. Yeah. Now the reason why inserting the reason I'm inserting quotations around these names is because they are string variables, and because this is a number, is an integer specified in this particular place, I don't need to insert a particular quotation to it. So now let's run this code, and now check checking our data sets, our database table students. Yeah, so to check it, there's something I used to do actually. I'll create a view. A view is just like a temporary table that allows me to um, check any particular information I decide to check as specified by my query, because I don't want to be running a particular query over and over and over again actually. So sometimes called a duplicate table, and I will show you why I am doing it as well. So students students info, yeah. Okay, looks weird. Okay, I don't think there's an error. So it's fetching my information, then we refresh this. I'll go to my view. So you can see these are my three values are inserted here. At this. So we've talked about the let me use this. Basically we about the talked about the relational database. Talked about the how to import and create tables. We've talked about views in SQL. Then the next thing for us to talk about now is, where is my course outline? Okay, I've seen it. Writing basic SQL queries like the select statements, the where statements, the order by, and the group by statements. Okay. Moving on. Basic SQL statements. Okay. No. Okay, it doesn't work. Select statements in SQL. So it is basically like a filter statement in SQL. It basically allows us to select, retrieve information based on some particular criteria.
Sorry, please, before we move, I want to ask this. You talked about creating a table. Either we can use query or the URL table.
Yeah, yeah, yeah.
That's no, I created some stuff in that URL table, and I had an issue with one of the row. I wanted to delete it. I could not delete it. Is
Um,
it, if we want to delete, is it through the query we'll still go back to delete it, or we can delete it right from that URL table?
if you've converted it into a database, like you've already gone to this particular tab and you want to delete it, you delete it from using
Uh,
the query. You
okay.
use the alter statement in SQL. But if you've not gotten to this particular place and you want to delete a particular column, you will
Mm.
just right click on the column and delete it.
Right click.
Yes, on that particular column
Okay.
and delete
Okay.
it.
Okay. I'll try that again.
Okay, so that's a very good
Thank you.
question actually. Is there another question you want to ask before I move on to the select statement in SQL?
I think my major issue was this that URL table connecting it with a database.
Oh, you just go to database. and go to forward engineer. In this case, you will see a forward engineer because we are not in the ER
Yes, yes.
diagram
You know,
part.
I was able to do the first one, but I now like okay, it created another database about two or three, so I was not having an issue to link it, creating a table to link it with that database. It was just
Is it
somehow.
on creating? Is it when you're trying to create a connection between, like a relationship between the two tables, or when you um when you've actually created the ER diagram finish and want to turn it to a database?
Yes.
Okay, yeah, you go to go to click on database, forward engineer, then just follow the just click on next and enter your password because it's going to ask for your password at a particular point
Mm.
in time. Enter the password and then you are good to go. But sometimes it brings error message because sometimes there is always an error in the query. I don't know, I've experienced it before. So what I do is I don't know, when I go back to, there's a particular place whereby it writes the query for me before, I think it's the last stage when you click on, before you click on finish. I'll go back to that particular part and copy all those error codes, paste it on ChatGPT to help me correct it by myself, sorry, by itself. Then I will copy the corrected code, paste it back on my like query tab, this query tab, then it will run for me. Like I have said in the previous classes that those ER diagrams are also SQL queries, but instead of us actually writing the query, it allows us to give us a drag and drop. So even these tables that we are creating, you can actually do a drag and drop here. I will show you something. If you click on this table, right click on it, click on create tables, it is going to give us some information. So basically like what we did on the ER diagram part. So it allows option for drag and drop as well, but it is not professional. That's why you cannot see majority of people. I don't know if you might have been going through LinkedIn, Twitter. You cannot see them creating tables like this because it is not professional. But you can actually do it as well. Maybe they might be doing it that they are not showing it online, but you can do it. But do not showcase it online because to me it doesn't showcase professionalism. So that's just it actually. So I don't want to save it. So let's go back to this part. Is there any other question?
For the now, no.
Okay, but what we've been doing so far is well understood, right? Okay, then okay. So to select, I want to select my name. Okay, let me not select my. I'm selecting my matric number. Not for my matric number. Oh, made a mistake actually. This is supposed to be a matric number when you are dealing with a standard school database. Okay, let me even go to an advanced stuff. This database that I'm creating can actually be applied to a back end, like a school database, for example, like a school website, for example. The back end of the website, or don't let me go there. Actually, I don't want to complicate things. Actually, don't let me go there. Okay, moving on.
No, please don't, please don't. You know, I was even about to ask you because when you talked about this VS code, so I was looking at, is this one we are doing now, is it a back end?
No,
If we want to make use of it in a front end, what can we use to bring it out? Because like let's assume like this web design stuff now. In those days, that time when I started that time long ago, like 2010,
okay,
the PHP, Java, they are the back end. You can
yeah,
use your normal, even the Dreamweaver was the back end. You can use your normal this is to pull it up, so that when so I was just trying to. I said I will ask you, though I just forgot that this one we are doing now. Because it doesn't really look like front end to me. Oh.
no. This is
Because
not a front end, and it's not a back end as well. This is just a database, but you know that every okay, since we are talking about websites, let me just give us this insight. Every website has a database that they will store their details. It's not necessarily informations. It can be let's take a look at Jumia, for example. Jumia stores the pictures of their phones, their accessories, anything they are selling in their database. So whenever we click on it, whenever I click on it from the Jumia website, the backend is going to request information from this database that we are creating. So this is not a backend; it is just a storehouse, or like a file whereby they retrieve information. So that's what I was saying, that this SQL that we are doing is not only attached to data analysis, and if we want to further our career on probably back end, we are going to be needing it. So that's just it. Yeah, I believe I've answered your question. Okay. Moving on. Now let's say we want to select this particular information about person with an ID of 1001. So what we are going to do is select star from um, student information, where we look at the column name student underscore ID is equals to 1001. Since it's an integer, we don't need to include an you don't need to include an I'm coming. Yeah, we don't need to include an a semicolon. So we run this code, and okay. um so you can see that because my name, because Stanley Agam is the only one with an ID of 1001, that's why it only returns only my value. And the reason why I brought out this is because whenever they want to retrieve information about a particular person among a large number of people data in that scenario, they use the magic number, like I've said, or something that makes it unique, that attach a name to each person. Like you, for example, you in the place of in your place of work, let's say you have a particular ID in your ID card attached to only you. So whenever they want to bring out information, they will just look up your ID to get all the details about you. It's even used in police situations. Like I don't know if if you watch American movies as well. All you just need to do is just look at your tag or your place number in your motor. All those things are primary keys, and so it's not just limited to data analysis as well. But since I focused on data analysis, um, let's just continue. Okay, so we can also treat something called like statements in SQL. Sorry, like statements in SQL. So no, not this schema. What's the mobile? Okay, what's the mobile table? Student info, yeah. Students info. Here, coming. I'm trying to check the column so I don't make a mistake. Okay, student's name. Where's student's name? Like okay, now so what I did here is that I'm trying to select all students. If I'm trying to select all the student details that has um that has that their first name starts with the letter S. Let's put it that way, or that has S in their name actually. So when I run this code, I'm going to get Stanley Abraham. Okay, now let me use okay, let me use T. Okay, use things on as a name like okay. I'm coming. Let me decipher the error. Oh, okay. I think I made a mistake here. Okay. Okay, something is not right. Should be giving me another name, not 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 the same particular name. Okay, I know what I'm going to do. Let's try SE. Yeah, just give me Sanusi Tunde. Yeah. Okay, let's try that. Yeah. Okay. So Sanusi Tunde. So I believe we already understood what this like statements mean. It brings us a particular name of a person that starts with this statement I've written SE, for example. Okay. Moving on. So we've talked about the select statement and the where clause actually. Where is basically providing a granularity. So let me use another data set. I think this is a large data 8 visualization. Okay. Yes. Use practice. So I want to show us the where clause and how it actually works. So select star from our table. It's visualization. Oh, we might even have done it before when we're using the select statements. Okay, we didn't do it actually. Um, where age is equals to 30. Okay, age is equals to 30 and um, lot type lot type is equals to be a okay, yeah, it's going to be a string actually, be negative. Okay, so let's run this. So you can see these are the old scenarios whereby we have age of 30 who are 30 years of age and have a blood type of B negative. So you can see Joshua Lawson, Patrick Cox, Angela Moore, Scott Nelson, and so on and so forth. So we've talked about the select statements, the where statements, the blood type. So moving on, let me go back to the course outline. Okay, order by and group by. Before we now talk about the aggregation function, and then joins in SQL. So the order by statements. Okay, the order by and group by statements. So let me just copy this query basically. So group by allows us to, um, I don't want to use the word cluster. It allows us to group, like the word says, group our data based on similar cases. Like for example, this particular case, we can group them by similar medical conditions. So okay, so you can use group by medical conditions. Sorry, that was a mistake. Medical conditions, right? Sorry. Medical conditions order by um, um, order by should I order by blood type. Let's do it that way. Okay, so let me drag this up so you can see it better. So you can see these are the old people which who are 30 years of age, B negative blood type, and have some medical conditions. But let's even do it this way. Then let us select this star means you're selecting every colon. So what we just need is we want to select name. Okay, yeah, name is a keyword which requires me to select name. I want gender as well because in just P2 they will require your gender info. I want blood type, and I want medical conditions. So we are selecting the name, gender, blood type, and medical conditions. So basically we're expecting 4 colons. Sorry. Okay. Let me check. Okay, yeah, this is not supposed to be an S, and there is not supposed to be an S here. So okay. Okay, there's an error as well which I need to decipher as well. Okay, yeah, I think I've seen the error. Since you are selecting multiple conditions and want to use the group by condition, we also have to group by as many columns as selected. So group by in the same order actually. So name, um, gender, sorry, yeah, gender, um, starts from here. Name, um gender. Okay, yeah, I've seen my error. Name, gender, blood type, then medical condition, okay. So let's run this. Sorry, medical condition, yeah. Okay, now this is a very standard way in which they will go. So this way you've already known which one is which. Already known Teresa is a female. She has a blood type of B negative. She has an asthma. So this allows us to, basically drill down each and every single person. So I believe already known the function of select statements, where statements, group by function, and order by statements. Now, uh, we need to, use the count state the aggregate columns, aggregate statement. Sorry, aggregate statements in SQL. So I'm going to copy the same code, and I want to use the aggregate statement on it. Okay. Okay, let us use this one actually. Let's count patients per medical condition. Okay. So we've basically started the analysis, extracting insights from our information, but in this case, in the medical sector, health sector, basically, not a student sector, because I want to make an example of this data set that we're using. I'll also be sending this data set actually. So if you want to import your data set, just click on this schema, right click, and okay, table data import wizard, and click on it. Then click on data you want to import. Then you click on the particular healthcare data set which I'll be sending to us as well. Okay, so count patients per medical condition. So I'll be selecting medical condition. Then I'll use the count function. I've already known from Excel what count statement basically means. This is called an alias statement. Whenever I use an as in my SQL, you're basically it's usually called an alias statement. You're trying to rename something on something. So from okay, um, trying not to make a mistake. As visualization. Yeah, I get the spelling right. Okay, then you use our where clause where age is equals to 30. Okay, yeah, equals to 30. And in this equality signs, there are various cases. We have not equals to, which you write like less than or equals to. We want to use greater than or equals to, use this greater than or equals to 30. and blood type is equals to B negative, then order by medical condition, and group by uh, total patients, okay, sorry, which is our alias name, so and descending. Okay, why am I okay? Yeah, I made a mistake. Group by, it has even told me actually, so obviously, yeah, order by. So this order by, basically, like we said, is basically an arrangement to present your output, your data. Is it going to be in an ascending order or in a descending order? So this total patients is an earlier statement that we created here. So it's counting all the colon, all the responses, basically all the colon actually, like this, for example, but across all the data sets, and it's counting it and naming its total patients, and from your data set, which is hospitalization, and this is the filter where age is equal to 30 and blood type is equal to B negative. So the people we are dealing with are people with 30 years of age and a B negative blood type, and we are grouping them by their medical condition, and total. I'm going to order them. I'm going to present them in a descending order. So let's run this code. Why do I keep getting the spelling wrong? Medical condition. It's actually correct. Okay. I'm coming. Let me check this again. Yeah, medical condition. Okay, so where can the error be from? let's leave the group by for now. Actually, I'm going to get back to that. So you can see, like I said, you're applying. Okay, there's something wrong with code actually, and trying to figure it out. Okay, yeah. So yeah, this works actually. So basically, what I did was I selected medical condition, count all the colon, and rename it as total patients. So from H visualization, our database where age is equals to 30 and blood group is equals to B minus. So basically, um, all people with 30 years of age and a blood group of B negative, these are the total of people that has cancer, asthma, obesity, diabetics, and arthritis. And we've already checked from our first what was it here, from this particular code. Okay, it's not this one actually. This is one error. Yeah, I think it's this one. Okay, yeah. What do I want to say? Yeah, I've already checked that and saw that majority of our um might have mistakenly deleted the code I didn't want to delete actually. I can't remember what I did. Okay. Age and P negative. Yeah, we've already seen people with 30 years of age. Yeah, I think I remember what they did. Um, yeah, this is what we did before we start using the. Okay, yeah, this is what we did basically, and it's still here. Okay, not this one. Select. Um, yes, I'm trying to remember what we did. We did name. I'm trying to relate those two analyses together, which I will show you right now. We did gender, and we did blood type. Okay. Yeah, so this is what we did first. Okay. Basic exploration. Then after that, I used to do this. Now I'm going to cut this and I'm going to paste it over here so we can have an idea of what we're doing. So as you can see, we've seen a number of people with negative blood group B, and we've seen their gender as well. So now, based on these status, and you can already know that these people are people with 30 years of age. In fact, let me even include age as well in the query. Age. Okay, sorry. Yeah. Yeah, as you can see, these are people with status of age and B negative blood group, and you can see we've seen them already. Now, this data is what we'll be working with in order to get this particular one, which we are trying to check people with and people with medical conditions based on their um, based on their age. And you can see that people with status of age have these medical conditions: cancer, asthma, obesity, diabetes, hypertension, arthritis. So people with status of age, these are the diseases they have. For 30 years old, okay, let me write 30 years old people, patients, sorry, because we're dealing with healthcare. These are the key things we need to know. So I'll copy this code and I'll paste it here. I'll cut this one as well because I don't want it to, scatter the whole process. I'll paste it here. I'll also cut this one. I'll paste it here. And I'll also create else. Oh, sorry. Create zero else as okay. Okay, then the alter statement. Okay, so we've already checked their age as well. Then we check their medical conditions. Now I want to do for 40 years of age. This is for 30 years of age people. I want to do for 40 years of age. For 40 years old patients. So I'll just change this to 40. In fact, okay, let's start from the youths. Um, let's start from the youths. I want to do it based on age. So we start from the youths, then move to the 30 plus, 40 plus, 50 plus, so you can know the type of diseases that is common across each age groups. So whenever a client gives you work, you can actually know, how to present your report. Okay, people with 20 years of age are more likely to have this type of disease based on our data that we've collected so far. 30 years of age plus are likely to have diabetes, like we've shown here, which is basically weird because 30 years of age is too young to have diabetes, but it's actually shown here in our data that they can have diabetes, and it's even the highest actually. But I don't know. Probably this is not a Nigerian data set. I don't know the country they are, which can actually affect what is going on in their um, company. So that is why it's even better to drill down per country so you will know what you are working with. The way Nigerian health is not going to be the same way as the health state of United States is. So I think it's even rare to have malaria over the United States. I don't know, probably because of the way they're facing something. I don't know. I don't really want to go into it. So for the youth, so, and according to me, 25 and lesser than 25 are classified as youth. So less than or equals to 25. Okay, and I don't need to. Okay, let's work with the negative low type as well. Let's say this is going to be what I'm working with. So oh, I put greater than or equals to 25. My bad. Less than or equals to 25. Okay, so these are the people lesser than or equals to 25. Oh, okay, you can see Larry Rogers, 23 years of age, um, and you can see the gender as well. Then, what else do you want to do? Their medical conditions and the most likely disease for them to have across um, their age group. I will rename this instead of aggregate function exist, since you've gotten what I mean. I'm going to write likely disease to have in the youth stage, and instead of 30 I'm going to write 25 as well, and less than or equal to 25. Sorry, that is not supposed to happen. Okay. uh this is definitely not the Nigerian data set. So it's telling me that the youth are more likely to have an hypertension and even more likely to have diseases compared to 30 years of age. Oh, I wrote greater than 20 equals to 25. Okay, this is less than. Yeah, it's less than. Saying 30 years of 30 people had an hypertension. The some people has an arthritis, 25 asthma, 30 people have diabetes. Okay, now let's go to the old people. Old age. I'm going to copy this. Sorry, I don't want to be writing the same code over and over again. Basically, that's what I'm doing. So that's why I'm trying to 60 instead of less than. This time it's going to be greater than or equals to 60, or probably because of the blood type. Actually, blood type can also influence our decision. So let me just remove this blood type. Let me copy this and paste it. We've done with the blood type of B positive. I'll check. Let's check without the blood type. Maybe the blood type is also part of what is affecting our results. um, Trying to get the different type of blood we have. Okay, we have A plus. I'm going to copy this. I'm going to write for A plus, and I'm going to do without blood group as well. I will remove this. Without blood group. That's still crazy. Diabetes is still leading 268. So two things. I don't know. This is not Nigerian data set obviously, and I don't know if this is actually a real data set or a dummy data set, because this is not normal. At least, yeah. Who are the age of 25? Well, cancer, hypertension of 34 people, obesity 244. I don't know. Is what data says actually. So I don't know which country they got this from, but I don't know. Let's continue. So the old age, yeah, this is done their blood type as well. So you've seen this. Then okay, like I said, 60 is my cut point. Greater than or equals to 60. So a partition of 91. I'm even starting to think the younger people even has more disease than the old age, because when we check the younger ones, okay, this is for A plus actually. We can see that you have a lot of okay, wait, okay, yeah, the other one actually has more disease. As you can see, hypertension is 31, 30, 25, 27, 34, 45. This is 91, 96, 97. Yeah, so the older ones actually has more disease than the younger ones. Do you have any question? Um,
No, really now. Until if one no one I do the practice now, I'm getting them.
okay,
So whenever I have issue, I will let you know.
okay. So I'll be sending the test as well actually, and some of the things I did. I'll send my query too, so you can actually check it and also see some of the things I did.
Okay.
So I think we basically covered everything on week 3. Week 4 is the last SQL part. We've covered the aggregate function as well. If you check the course outline, the main thing left is joins and subqueries and command table expressions, which we'll be covering in the next class. We basically is 1 hour 30 minutes actually. Yeah. So like I said, I'm recording this video already, so I'll paste it this night. So thank you very much for for your attention. Okay, you said you have any question.
No.
Oh, you
Well,
said
please can you help me paste the course outline again? My WhatsApp crashed, so I lost those information.
okay, no problem then. But you understood what we
So
did
at
so
your
far.
leisure time.
You understood what we did
Yes,
so
yes,
far. The
yes.
concept of a
Thank you
relational
very much. Yes.
database.
Mm.
Okay then. Yeah. Do have a
Thank
nice
you.
day.
Thank you very much.